All right, so we have one more secret to reveal to you about how bonding works, and we're going to introduce this. I'm going to introduce this to you using carbon dioxide, a molecule you know and love. In fact, you've been making it your entire life. You've probably heard of it before. It's good old CO2. So anytime we're going to draw a molecule, this is also going to be a great reminder of these first 4 steps. Remember, the first thing that we need to do with that molecule is we have got to sum the valence electrons. That's right, we've got to count up all of the valence electrons that are in it. So we look up carbon on the periodic table, we see it is in group 14, therefore it has 4 valence electrons. And we look up oxygen, we see oxygen's in group 16, therefore it has 6 valence electrons. And we remember that there are 2 oxygens. Then we have to remember PEMDAS, please excuse my dear Aunt Sally. We multiply those 2 numbers before we add any numbers, and we get that there are 16 electrons in here. Step 2 then shows up, and step 2 is that we need to draw the central atom. And so we got to look here and we got to decide what's going to be our central atom. Is it going to be carbon or is it going to be oxygen? And the no-duh rule applies here, right? Subpart A of that one. There's only one carbon, so therefore carbon is going to be our central atom. I'm going to draw it nice and large there. All right, so from there we go on to step 3. We need to draw our surrounding atoms and bond them back to the central atom. So we'll start over here on the left. We'll put an oxygen over there and we draw a bond to carbon. And notice also, I have marked out some electrons and I put 2 electrons. I took away 2 electrons because that bond has 2 electrons in it. Now we put the atom on the right and we bond it back to the carbon, right? And that oxygen right there, it uses up 2 more electrons. We're down to 12 electrons left in this atom. Then step number 4 comes up. We need to fulfill the octet here, right? So we got to look at one atom, and remember I gave you the hint that you need to start with your central atom. So we're going to cover everything up but our central atom, but carbon. And we notice it has those 2 bonds on it. What do those 2 bonds have in them? Well, each of them has 2 electrons. So 2 on the left, 2 on the right. We've got 4 electrons around it. It needs an octet, which is 8. So we are missing 4 electrons around carbon. We're going to put those on there by adding dots. First 2 on the bottom, then 2 on the top. That 4 electrons, I take those out of the 12, I'm left with 8 electrons. Carbon has a full octet. Now we worry about the other atoms, and we look here and we remember that what I've got is I've got 8 electrons left. And remember, what we're going to do is we're going to split those amongst the surrounding atoms right here. So 4 of them go to the oxygen on the left, 4 of them go to the oxygen on the right. And that leaves me with no electrons left to put in this atom. So do we have a full octet on every atom here? Well, I'm going to start by looking at one of these oxygens. And to do that, I'm going to cover up everything else. And I'm going to count how many electrons I have around this oxygen. Well, there's 1, 2, 3, 4. And then the bond, which is 2, so 5 and 6. This thing only has 6 electrons. It's not a hextet, it's an octet. I need 2 more electrons, but I don't have any more, right? I've already marked out all of my electrons. I don't have any more to put into this. So normally, here's where you'd start pulling out your hair and running around screaming and hollering, but no, there is a much simpler solution. And it goes back to an old Southern tradition. If you're sitting at home baking and you run out of sugar, you say, I ain't got no more sugar in the pantry. What do? You walk to your neighbor and you borrow some sugar. And so that's exactly what we're going to see happen here. Oxygen is missing electrons, but carbon right next door has a bounty of electrons. It has tons of electrons, plenty to share. So what we're going to do here, what we're going to see happening here, is that carbon is going to lend some of its electrons to the oxygen. And in so doing, it can't just give them away, right? If it gave them away, now carbon wouldn't have a full octet. We're going to freak out. You know, dogs are going to be living with cats and the whole world's going to catch fire. No, that's not going to happen. What we're going to see happening here is it's going to share those electrons. And so the electrons disappear from carbon and reappear as another bond. That right there is 2 lines between oxygen and carbons. That means that there are twice as many electrons being shared. That's right, they are sharing 4 electrons between them. We're going to talk about what that means in just a second. But first, we're going to take care of this one over here on the right. That oxygen's in the same bucket. It only has 6. So we're going to take the 2 from carbon, move them over to make a nice 2 lines over there in between that carbon and oxygen as well. And what do we call those things? We call those double bonds. So the very last step that you need to know to be able to draw all these bond diagrams, go ahead and add that to your notes, is that we are going to draw double and triple bonds to try and fulfill the octet. Right? We've got to fulfill the octet. Some people count this as kind of a subpart of step 4. Nah, I don't like that. This is its own step, right? When you get to the very end, you can't match the full octet on those last atoms. We're going to go back in and see if we can move some electrons to make double or even triple bonds. And that's pretty important. The last clue I'm going to give you has to do with those weird charges that we see in some of these on the back of this sheet. And a lot of people were flipping out about that. They're like, oh, this is going to be difficult. It's actually not that difficult. What this does is it actually changes that step 1. So when I'm going through here and I start adding up electrons, remember carbon has 4, oxygen has 6, but oh yeah, there are 3 oxygens. Do the multiplication before you add those 2 up and you get not 16. Oh my goodness, that is not 16. What number is that? That is 22. 22 electrons is what you get because it's 18 plus 4. So because we have 22 electrons, this other number is also going to be wrong. There we go. 18 plus 4 gives me 22 electrons. It's pretty late at night for me to be doing some basic math, wouldn't you say? But anyways, back to this. All right, so that part's just like normal, but now we've got that -2 to worry about. And you remember that electrons are negatively charged. That's why there's that little minus sign on the electron, right? So if it's negatively charged, what that means is that that structure has 2 extra electrons. So at the very end here, we're going to add 2 more electrons for that -2, which means that this thing actually doesn't have 26. 22 plus 2 is 24 electrons. There we go. Doggone it. Why did it... Well, let me change that to... You get the point. You get what's going on here. 24 electrons. Check. 24 electrons. So whenever I draw a carbonate, I'm going to do all the steps that I did before, except now instead of starting, remember with carbon dioxide up there, we had 16 electrons. Now we're going to have this structure and it's going to have 24 electrons. It's pretty neat. With that, you should be able to finish the entire sheet. I want you to practice that as a group, in your groups, until you're satisfied with your ability to be able to draw these.